Have you ever noticed how a concave lens always makes things look smaller? Today, let's learn step by step how to draw ray diagrams for concave lenses. And you'll see why the image is always virtual, upright, and diminished. A concave lens is also called a diverging lens because it spreads out light rays. To draw ray diagrams, remember these important parts. The first one, principal axis. This is the main horizontal line. Second, the optical center or the vertex. This is the exact center of the lens. And the third one, focal points. This is located on both sides at equal distance from the center. But here's the trick. For a concave lens, rays seem to come from the focal point, not pass through it. To find the image, we just need two rays. Ray 1, this is a ray parallel to the principal axis. And after passing through the lens, it bends outward but looks like it came from the focal point on the same side. Next, ray 2. This is a ray heading straight toward the optical center or the vertex. This one goes through the lens without bending. Let's draw an example. Suppose we place an object in front of the concave lens. First, draw ray 1. From the top of the object, parallel to the axis, and then refract it outward, extend the refracted ray backward and it should pass through the focal point. Next, draw ray 2. From the top of the object, straight through the optical center or the vertex. And where the extended rays meet is where the image is formed. And what do we notice? The image is always upright, diminished, and virtual, no matter where you place the object. That's why concave lenses are used in glasses for nearsighted people, in peepholes of doors, and other devices where we need a wider field of view. So remember, a concave lens always forms an image that is virtual, upright, and smaller. Just follow the two main rays and you'll never get confused. And if this video helped you, don't forget to hit like, subscribe, and share with your classmates.